Probabilities from two-way tables. We have a class of students who were surveyed on whether they like maths and whether they like English. These are two different experiments or two different variables, whether they like maths and whether they like English. Because there are two different questions here, we can put one of them on the top and one of them down the side. And these are the outcomes for whether a student likes maths. Either they like it or they don't like it. And these are the outcomes for whether a student likes English. Either they like it or they don't like it. That is why it is a two-way table. Good. So there are some questions about probability here, and we can answer some interesting ones like, if you like maths, does that make you more likely to like English? Or does that make you more likely to hate English? Do people who like English generally like maths? And so on. All sorts of interesting things like that. But first, just to get our heads clear, let's look at what these things mean. I have 7 students here that like maths and also like English. I have 3 students that don't like maths but do like English. So in total, there are 10 students that like English. How many students don't like English? Well, there are 5 students who don't like English but do like maths. There are 11 students that don't like English and don't like maths. So there are 16 students who don't like English in total. Okay, and we can do the same for the number of students that like maths. 7 students plus 5 students is 12. 3 plus 11 is 14. To figure out the total, you might be wondering, hang on, this total bit here, do I add up the numbers above or the numbers to the left? And the answer is, it doesn't matter. Either way, you'll get the total number of students in the class. For example, out of the whole class, 10 like English and 16 don't like English. 10 plus 16 is 26. There are 26 students in the class, 10 of them like English and 16 don't. Another way of getting this number is saying, okay, there are 12 students who like maths, plus 14 students who don't like maths, so in total there are 26 students. So this number here, it doesn't matter if you add up those two numbers or those two numbers. All right, let's answer some questions. What does the number 3 in the table represent? The 3 is right here, and it represents the 3 students that like English, but they don't like maths. 3 people like English, but do not like maths. What does the 10 represent? Well, the 10 is the total number of students who like English. 10 students like English. What does the 26 represent? Well, that's just the total number of students in the class. There are a total of 26 students in the class. Now we can look at probabilities. We can estimate the probability that a randomly selected student likes maths but doesn't like English. How many students like maths but don't like English? They like maths but don't like English. There are 5. So that's 5 students out of 26 in total. So we can say therefore, the probability of maths but not English. Do you see how I've tried to write the event here nice and short to make it easier for me to write, but also clear enough that people can understand what it means? The probability of liking maths but not liking English is 5 out of 26. And we could get this as a decimal. I did 5 divided by 26 on my calculator, and I've used the approximately equal sign here because I've rounded it off to 2 decimal places. What about the probability that a student likes maths given that they like English? This is a different kind of question. So this says, out of the students that like English, so I'm not picking a random student from the whole class, I'm just picking a student out of the students that like English, out of these 10 students that like English, if I randomly pick one of them, how many of those 10 students like maths? Out of those 10 students, 7 of them like maths. and 3 don't like maths. So there are 7 students out of 10 students. I'm not doing it out of the whole class, I'm doing it out of the students that like English. When you see given that they like English, you can imagine that as out of the students that like English, out of that group. Okay, so 7 students out of 10. So the probability of liking maths, given that they like English, so out of that group, is 7 out of 10, which is 0.7. And that, my friends, is how you can use two-way probabilities to calculate not just probabilities, but probabilities given a certain fact, which is fascinating. There are all sorts of interesting things you can look at, like the chance that someone coughs given that they have coronavirus is probably quite high. But the chance that someone has coronavirus given that they've just coughed, it's probably quite low because there are so many people who just have a cold or a sore throat. So a lot of interesting probability things to explore there. Anyway, I'll let you get stuck into that later. I hope this has been helpful, and I'll see you all next time. Bye, everyone.